Alright, good afternoon everyone. Today I'm going to be showing you how to draw ray diagrams for a parallel mirror problem. Now, these parallel mirror problems are going to show up a lot throughout this unit of physics. The big thing about them is we have two mirrors that are side by side in some form of object that's being reflected. I think I promised you gold stars on your test, so I can give you gold stars to place places. Now, here we have this nice little black and white domino. It's really handy because it allows us to see the different ways that we might be looking at an object. It'll get reflected across and we can easily see if the image changes direction. The other thing we have is an eyeball down here. This represents you looking into this parallel mirror setup. We have mirrors 1 and mirror 2. Now the first thing I do with any of these is I reflect my mirrors in each other. Now, one handy trick that I have found for the layout in the packet is that essentially the spacing between the two, and we want to be careful to measure. In this case, I see the spacing at about 25, 26, a little over 27 millimeters. I'm going to approximate that as the width of one ruler. Put my ruler between them, and I'm going to create my mirror reflections using my ruler on either side. Because my ruler is essentially the spacing between those two lines. And yes, that was on purpose. We wanted to give you a simple way to copy down a mirror diagram, so that most of our classroom rulers are about the width of that distance between the two lines. So mirror 1 gets reflected in mirror 2, creating an image of mirror 1. Mirror 2 gets reflected in mirror 1, creating an image of mirror 2. Mirror 1 gets reflected in the image of mirror 2, and yes, we are going to have to go out to a number of these. Mirror 1 gets reflected in the image of mirror 2, giving us mirror 1, but it's no longer reflected in an original object, it's now reflected in a reflection. So that's going to be a secondary reflection of mirror 1. Over here, you're going to see we've got a reflection of mirror 2 in mirror 1, so we're going to get a secondary reflection of mirror 2. Alright, our mirrors are drawn. Next up, we have our object here. And one thing I remember from before is our object's roughly, we changed the dimensions on that object between the two problems. Be careful with that. Originally, our object was about 10 millimeters. But now we're looking at an object that is a little bit more along the lines of between 12 and 13 millimeters. I'm going to call it 12 for the sake of simplicity. So what we're going to do is we're going to measure the distance from that object to the mirrors. We're going to transfer that distance to the other side, taking care to draw our images at about the same height. You'll note that I am trying to take some care to be moderately close to my original dimensions, because that's going to matter when we draw our eventual ray diagrams. I'm again just copying a drawing of that to the exact distance on the other side of the mirror to create my primary image. The side of the object that faces the mirror in the image. So the black side faces the mirror, in the image my black side faces the mirror. Over here, you'll notice that I'm looking at about a little over 12 millimeters, 12 and a half. And then I'm going to start my object right there. Again, trying to be pretty close on the height of my images so that things relatively match up. Here the white side faces the mirror, so the white side's going to face the mirror when it comes over here. This is also a primary image of our object. I'm going to keep continuing that, and I am going to draw my remaining images. These don't need to be perfect, but the better you do at having some level of precision, the better your final result will be. So now I've drawn my primary image. The next image out is a secondary image. After that, I need to keep measuring my spacing, and this is where careful measurement pays off. I wasn't too careful with some of my measurements, and I'm finding that my objects are starting to get spread out a little differently. My measurements each time are a little different. It just creates a poor looking diagram in the end. There we go. So here we have our original object, an image of our original object, a secondary image of our original object, so that is a reflection of the object, and our tertiary, which is a reflection of a reflection of a reflection of the object. Now we were told we need to draw to the tertiary image on the left side, so we have a little more drawing ahead of us. We have to draw out that next image over here. Once we get to a tertiary image on this side, we'll be able to stop. So right here is a secondary image. And you'll see when we get to our ray diagrams that you will need all your images on either side. There we go. That is a tertiary or third image of our original object. Here's our secondary on that side. Alright, so your first steps were copy your mirrors down and make your mirror images of each mirror an equal distance behind the other mirror. Our next step was to repeat this process and copy down images of our original object. Now, a common question is, how did I know to stop when I only had 2 mirrors on the table? Well, you need 1 fewer mirror image than you do reflection. So, for instance, if I'm looking at the third image on the left side, I need at least 2 mirrors. I'm also going to need all of the images on either side because we're going to follow the same process we would for a 90-degree mirror. That process is that we will start with the image we're looking at. We're looking at the tertiary image on the left side. And we're going to draw our line of sight. With something like this, I just like to draw to the corner. We'll line our ruler up so that the eye and the corner of that object are all in alignment. Now we'll come down here, solid line to the first mirror, and then we're going to do a dashed line after the first mirror. This again represents the line of sight, which is the line our brain thinks that light took when it was traveling here. Our brain looks into a mirror and it says, oh hey look, there's stuff back there, but there's not. Now the next thing we do is we apply the law of reflection. The law of reflection states that we will reflect off of a surface at the same angle we struck it at. So if this is the angle we hit the surface at, that's the same angle on the other side it'll bounce off at. Excuse me. Now, we can use a hack to apply that rule, but we were aiming at the dark corner here. So now we'll go over to the secondary image. We'll reflect to the secondary image on the other side, line up where it struck the mirror with that corner, and we will bounce to the other side. Then we started looking at 3, then we were looking at 2. Careful not to draw dotted lines anymore. You can't look at more than 1 image truly at a time. So we bounced to 2. Now we're going to go over here and we're going to bounce to 1. We're again lining up with the corner. My apologies, folks. You can tell I have not had my morning coffee yet, and I don't want to remake this video. The trick to this is that you're counting down. We start by aiming at the tertiary image, then we bounce to a secondary image, next we bounce to a primary image. A trick to help you is that if you were looking at the darkest corner of our image the first time, every bounce should be aligning with a dark corner when you have a domino like this. One of the ways I knew I had made a mistake is I was looking at this and I was like, why am I aiming at a light colored corner when I was looking at a dark colored corner? Each time we should be bouncing to the same spot on our object because the optical path, which we just drew, represents the path that light actually traveled at in the real world. So this light, right, a photon, bounced originally off our object, then bounced off the first mirror, then it bounced again off the second mirror, then it bounced again off the third mirror, before bouncing into our eye. You'll notice tertiary image, 1, 2, 3 bounces. It's a great way to check your work. Alright folks, this is how you make a parallel mirror diagram. Please let your teacher know if you have any questions. Thanks for watching.